Okay, Professor Hildebrandt here. As promised, hopefully you've already watched my chapter content lecture where I go through the PowerPoint slides, but now I'm going to work a few more specific examples on hypothesis testing from Chapter 10. This will probably be the first of probably a 3-example series. In this first one, I'm going to work a one-tailed test where we know our standard deviation. Again, if you haven't yet looked at the lecture, you need to watch that first. Okay, so if you're following along in your textbook, this is on page 334. I'm going to work question 2 from chapter 10. And so this is what we're told. A sample of 36 observations is selected from a normal population. The sample mean is 12. And so let me change my color here. So I've written that out for us. The sample mean is 12. And the population standard deviation is 3. And right, we were told the sample size, so n equals 36. Then we're asked to conduct the following test of hypothesis using a 0.1 significance level. And so they gave us here our null hypothesis is that the population mean will be less than or equal to 10. And so then our alternative hypothesis is that the population mean is actually greater than 10. And so let's go through our 6-step process and figure out what we can say about the hypothesis that we have. So the first part of the question asks you for all of these on exercises 1 through 4 in the text, is this a 1 or a 2-tailed test? Well, my intro kind of gave that away, but this is a 1-tailed test, okay? So that's the answer to part A. And how do we know it's a 1-tailed test? We know that because our alternate hypothesis here, H sub 1 is a range, and our null hypothesis is also a range. Remember, we only use the 2-tailed test when our null hypothesis equals a value, and then the alternate is that it does not equal that value. So this is going to be a 1-tailed test. All right, step 2 of our process, we have to figure out our decision rule. Remember, this is just figuring out the level of significance. So again, we were told to use 0.01. So we're going to use, in your textbooks, table B5. Okay, so if you have your textbook open, go to table B5. If you don't, maybe pause this for a second, get in your online textbook and open up this table, okay? You can connect to it from chapter 10, or you can find it in the table of contents. And so on table B5, first for our column, we're going to go with the 1-tailed. That's what our test is. So look for the 1-tailed with an alpha of 0.01. Okay, and so find that column. That's kind of step 1 here. And then for the row, you're going to down to the very last row where it says infinity. And this is always what we use, always used when calculating the level of significance. The degrees of freedom stuff is what we use if we're calculating a t-value, and I'll work a problem like that later. So, but to find your level of significance, you're always going to go to that last row. And so when we do this, we get 2.326. And so that's the value that we get. And so what are we going to say? Well, we're going to reject the null hypothesis if the z that we calculate for our sample is greater than 2.326. Because remember here, our alternate hypothesis is that the value is greater than 10. So that's the rejection region. So it's going to be the positive or the upper tail, the right tail. So let me just show you. Again, I think sometimes for some of you it helps to see our normal distribution here. And so what we were saying is here is our level of significance at 2.326. And so this shaded region here to the right is the, let's call it the rejection region. And so if, when we go to our next step and calculate our z, if our z is greater than 2.326, then we are going to reject the null. Okay, so that takes us to the C part of this question, which just says, what's the value of the test statistic? Again, because our standard deviation is known, then we are going to use our formula and find the z. And remember, our formula for the z is we take the sample mean, we subtract from that the population mean that we're testing against. We divide that then by taking the standard deviation and dividing by the square root of our sample size. So plugging in here, our z equals, we were told that the sample mean was 12. We're testing a population mean of 10. Our standard deviation was 3, and our sample size is 36. So work out the math. 12 minus 10 is 2. In our denominator, we'll have 3 now over 6, 6 being the square root of 36. I can further break this down. I can say this is 2 divided by, I'm going to reduce this fraction in the denominator. 3/6 becomes 1/2. If we are dividing by a fraction, we simply multiply by the reciprocal, so we invert that fraction there. This becomes 2 over 1. And so my answer here is my z is 4. That's the z that I found. So again, let's go back up to our distribution, and 4 would be somewhere probably over here. That's a z of 4. So our z value that we found is in the rejection region. Okay, and so that's the next question. Question D on this problem said, what is your decision regarding your null hypothesis? Well, we're in the rejection region, so we are going to reject that null hypothesis that said that our population mean was less than or equal to 10. And we're going to conclude then that our alternate hypothesis of the mean greater than 10 is true here. And then the last part E of this question, asks us to then find the p-value. And remember, this is the kind of probability that the calculations, the testing that we've done, what are the odds that it is correct? Okay, the probability that it's correct. So how are we going to go about finding this p-value? Well, we are going to use our z of 4, and we're going to take a look at the chart. So now this time you're looking not at table B5, I believe this is table B3, but it's the one for the z values. Okay, so go to your chart for your z values, and if you'll look and see, our table stops, it maxes out at a z of 3.9. And for a z of 3.9, the area is equal to 0.4990. But remember, we want to know the area that's in the tail. And so to find the area in the tail, we would do 0.5 minus 0.4990. And so we would have an area in the tail of 0.001 if our z was 3.9, right? But our z is not 3.9 here. Our z value was 4, which means that the area in our tail, going back to this picture here, so this area here is virtually 0 because it would be even smaller than the value of 0.001. And so then what can we conclude about this? Knowing that that's what our p-value would be is virtually, so we're saying here the p-value is basically 0. Okay, so what does that allow us to say? That tells us then our final conclusion is there is very little chance, okay, very, very little chance that that null hypothesis is true. So most likely we're going to go with the population mean is going to be a value greater than 10. Okay? Hopefully this helps, and again, look for a couple more examples to follow.